A common statistic that you may be needing to use in your data analysis is a correlation or a Pearson correlation. Essentially what a Pearson correlation does is it evaluates the relationship between two variables. Now remember about correlations that correlation does not equal causation. Therefore, just because two variables are correlated doesn't necessarily mean one causes the other to do that. Okay, so keep that in mind, and also be sure to review your stat book as you're using these correlations and analyzing these correlations, because you want to be sure that what you're doing actually makes sense from a research standpoint. So in order to run a correlation, you need two scale or ordinal variables. And so once you have those in there, I have a sample data set here that I have a achievement test score, self-directed learning score, and two cognitive style test scores. So once I have my data in, I'm going to go to Analyze, and then to Correlate. Now because I'm going to be showing relationships between two variables, I'm going to choose the bivariate option. Now this is a box where you can select the variables that you want to analyze in your data set. So here I have these 4 scores that I want to examine correlations. So I'm going to move each of those over into the variable boxes. I'm going to choose for the correlation coefficients, I'm going to run the Pearson, which is one of the more common types of correlations that you'll be familiar with. Test of significance is a two-tailed test, and I am going to flag statistic significant correlations. And I'm going to go and show you the options box. You can decide whether you want to display means and standard deviations. I'm going to go ahead and just continue and use the default settings. When you're ready to run your data, select OK. And you'll now notice that the correlation table has been presented here at the bottom of our output window. Now what's interesting in terms of interpreting these correlation windows, you notice that I have the variables listed across the top that I was analyzing, and I have those same variables listed down the rows here. Now you'll also notice that this table is a mirror image of itself. So for example, and there's separated by perfect correlations because there is a perfect correlation between the same variables essentially here. So score on self-directed scale is 0.627. If I go over here, score on self-directed scale and the self-achievement scale is 0.627. They're the same thing. So in order to interpret this table, all you need to know is really this sort of top triangle here. So what I'm going to be looking for here is statistically significant relationships between variables. And this all depends on where you set the level of significance. So for example, I notice that this one is set at the 0.01 level for two-tailed. And so I have the significance indicators here. So I'll look and looks like I have one statistically significant relationship here, and that's between the score on self-directed scale and the score on a self-achievement scale, and is a positive correlation. So this tells me that if the score on the self-achievement test goes up, so does the score on the self-directed scale. And I notice that that is a moderately strong correlation effect there. So by doing this, you can look through each of these variables, these associations, and determine what variables have relationships to one another. And this will help in your analysis as well. So in this tutorial, you've learned how to run a correlation coefficient statistic, and you've learned how to interpret the output from the SPSS file that has been presented to you. You'll also want to be familiar with how to write up the results from this, and the best way to do that is to consult your stat book that has examples of the narrative write-ups for the correlation coefficients.